What is station keeping for geostationary satellites? Imagine a satellite that stays perfectly above the same spot on Earth, providing constant communication or weather data. That's what geostationary satellites do, but keeping them in that exact spot takes some work. These satellites orbit about 35,786 kilometers above the equator. Because of this high altitude, they appear fixed in the sky to ground stations. But natural forces are always trying to move them out of position. The moon, the sun, and even the Earth's own shape cause tiny but continuous shifts in their orbit. Solar radiation pressure, caused by sunlight hitting the satellite, also pushes it slightly off course. Without intervention, these forces would make the satellite drift east or west along the orbit or tilt north or south. This drift can cause the satellite to lose coverage of its target area or interfere with neighboring satellites. That's why operators perform what is called station keeping. It involves small, carefully planned maneuvers using onboard thrusters. These thrusters burn fuel to correct the satellite's position and keep it aligned. There are two main types of corrections. North-south station keeping adjusts the satellite's inclination, which is how much it tilts north or south. The goal is to keep it close to 0 degrees inclination so it stays directly above the equator. East-west station keeping keeps the satellite at its assigned longitude, preventing it from drifting east or west along the orbit. This is important to avoid signal overlap or collisions with other satellites. Operators typically perform these maneuvers every 1 to 2 weeks. They carefully calculate how much fuel to use for each correction to extend the satellite's operational life. Fuel is limited, so efficient maneuvers are essential. When the fuel runs low, the satellite is moved to a higher orbit called a graveyard orbit. This prevents it from interfering with active satellites and keeps the space environment organized. Station keeping is vital for the satellite's ability to provide reliable services like television broadcasting, weather monitoring, and global communications. Advances in propulsion technology and better algorithms help extend satellite lifetimes and improve how these corrections are made. Managing multiple satellites in nearby slots also depends on precise station keeping to avoid collisions. In simple terms, station keeping is the ongoing effort to keep a satellite in its perfect spot in space. It's like a tiny, continuous balancing act that ensures the satellite stays in place, providing steady, uninterrupted service for everyone on the ground.